All right, so before you guys should compare your numbers. Clearly, you should have the same answer. We're looking for the force of attraction between this electron and proton in this fictitious atom. In doing so, you're going to have 1.6 times 10 to the 19th. That's the elementary charge, the same charge on both the electron and the proton. And yeah, you should technically make one negative and one positive, as we discussed yesterday. The true equation here for vector form has all of those features in it, but we know there should be an attractive force. And I asked for you to find the magnitude of that force, so the negative and the positive don't matter. In fact, you can just put 1.6 times 10 to the 19th squared. I'm sorry, I put 19th there. That's negative 19th. Don't get all mad. You had it in your notes from yesterday. 9 times 10 to the 9th for K. And then we're doing 2 times 10 to the negative 10th squared in the denominator. Now, do me a favor. Raise your hand if you're having the same number in your answer as the person next to you. Now, you tend to think that provides you with confidence. How many of you know a quick way to estimate your answer here, to know whether you're even in the ballpark? Anybody been taught like how to deal with these scientific notations and a way to do estimates? Only one of you? Okay. Look at these numbers real quick. I've got 1.6 times 10 to the negative 19th squared. I've got 9 times 10 to the 9th, which is pretty close to 1 times 10 to the 10th, right? In the denominator, I've got 2 times 10 to the negative 10th squared. If you want a quick estimate about the size of your answer, start by just looking at the exponents. When I have 19 squared, you just double the exponent. So e to the negative 36 for that number. And this is close to 1 times 10 to the 10th, so I'm going to just put 1 times 10 to the 10th. The bottom, again, just double the exponent. So 10 doubled is 20, so e to the negative 20. Now, the truth is, 1.6 squared, that's just a little bit less than 4, right? So I'm just going to put a 4 in here. And 2 squared is about 4, so I'm going to put a 4 here. I'm doing this because your calculator doesn't lie to you, but it gives you a false sense of your answer. If you really want to know what to do now, just add the exponents that are on the top and add the exponents that are on the bottom, and then subtract them. So on the top, I've got negative 36 and 10 is negative 26. On the bottom, I've just got negative 20. And then negative 26 minus negative 20 is negative 6. I expect my answer to be about that big. Your exponent should be something around negative 6. If it's not, you've screwed up. And you've probably screwed up something arithmetically in the way you put it into your calculator. Now, I don't know what the answer is, but I'm estimating it's going to be probably a little bit less than 1, so I might have 10 to the negative 5th. Or negative 7th. Five point, 79 times 10 to the negative 9th. 76 times 10 to the negative 9th. You plugged it all into your calculator correctly. That's a Newton. Now, what does an electron do around a proton? It orbits. That's right. So you cannot take this class without remembering that you at one time took another class. Except for all of you who have never had any physics before. So if we assume a circular orbit, could you figure out how long it takes to go around the atom? Do you remember that from last year? I am not asking you to do that. Listen closely to me. there's mechanics in here, and you're going to have to be able to remember your mechanics. If you don't have mechanics, then you're at a disadvantage. And there are going to be some things that are going to come up that you're probably going to have to review or maybe receive a little side instruction on until you cover it in your mechanics class. But there are things that were remembered from last year, like net force equals MAC. That's still in play here. Right? Newton's second law for an object in centripetal motion. And things like centripetal acceleration, v squared over r, or omega squared times r. Still in full swing here. And it goes more than this, if you'll recall, like frequency is 2 pi times angular frequency. Period is 1 over the frequency. Do you remember all these things? If you don't, we might need to do some review from time to time. We'll do it in line as we work. But you should be able to mash all those things together to figure out how long it's taking that electron to go around the atom or what the frequency of its orbit is. This should be enough where you could just mash it all together. All those letters work together. But I want to focus on Coulomb's law today, not these side pieces, okay? So this is low-hanging fruit, pretty straightforward. You want to see what you're really going to be up against? You have no choice. I'm in charge. So we'll stick with a one-dimensional problem, because why not? But don't assume that a one-dimensional problem is where we're going to stay. I just don't want to work in trig today because that might be too much for y'all. But we'll see. I know we're on club schedule, so I have limits. All right, so this is Q. This is 2Q. And they are separated by a distance of D. Right. I have another charge whose charge is unknown. How far away from this charge can I place the unknown charge so that it doesn't move? Now, before you launch this problem, there's not much to do here. I really have not changed the level of difficulty very much. However, you have an unknown charge, and I know that's going to freak you out a little bit. Just make it Q for now. Just give it a value. And then we'll evaluate if it's a problem for it being positive or negative later. Fair enough? Now, your responsibility is to kind of figure out the minutia of this problem. There's not a lot here, but there's a few little things. I'll remind you that Coulomb's law only works between two particles at a time. So you have to live within those confines. So I'm going to step through this problem a little at a time. There's not much here. But because of what I just said, do you realize the particle in the middle is experiencing two different forces? So lump them together. There's this force, which is a repulsive force, correct? Or it's an attractive force, correct? Let's assume the particle is positive for the time being and say it's a repulsive force. That will produce a force to the right. And then, of course, we can lump these two together. That make sense?
You guys can see okay, right? I'm not blocking you.
Well, again, if it's positive, then this will also be a repulsive force in this direction. Do you see that there is the possibility that these two forces could be equal? Our job is to figure out where that is. So with that in mind, I'm going to work the problem on each side. In yellow, I have that force, which is to the left, and that's going to be Q times 2Q times K over X. I don't have a distance there. I'm just going to call it X squared. And I'm going to label this distance X. I am creating a variable for this problem. It was not given to me in the problem, but I need something as a placeholder. I'm eventually going to solve for X, I think. All right, let's look at the green particle for a minute. How the green particle is experiencing a force that I think is to the right. Can we all agree it's to the right? And of course, it follows the same kind of rules. It's going to be Q times big Q times K over, what will I put in there for our separation distance? D minus X. That's right. D minus X squared. Now, either I say to the right is positive, and to the left, to the left. I either say to the right is positive and to the left is negative, which I think is a fair thing to do. If I do that, that makes this a positive force, and this a negative force. And I say in my problem, force to the right plus force to the left has to equal 0. Or if you're trying to save time, just set them equal to each other. That's what's going to happen anyways. I mean, technically this is right, making sure I make one positive and one negative because I have to deal with direction and I should make it on a number line and all that garbage. But do we all see that in the end, all that's going to happen is I'm going to have Q times K over D minus X squared is going to be equal to Q times 2Q times K over X squared. Right? Isn't that going to be the result? Now, this problem seems harder than it is until you reach this point. When you reach this point, almost everything cancels out. So I can cancel out the Q, Q, and K that's there, put a 1. I can cancel out everything here except for the 2. And then I'd probably just cross multiply and get X squared equals 2D minus X squared. Now, quite suddenly, this problem bores me. Does it bore you now? I mean, we did the physics. Now we're down to a quadratic. But I would like to say that bores me. I have concerns about your capabilities. So let's see it to the end. Can you give me an expression for X? It's important because it's a quadratic. There's 2 answers. I don't know that there's 2 answers here. I'll argue that this math is stupid and repetitive and boring. It has nothing to do with the problem, except that if you want the answer is going to be finding a solution for X. So can we all agree that the answer to this problem is going to be probably twofold, that there'll be 2 answers? All right. So the only way to do this is to expand. And I'm going to start by expanding the right-hand side and get our X squared equals 2. Binomial expansion, you square the first term, multiply 2 terms together and double it, and then square the second term, right? You guys learned that? So this is going to be d squared minus 2dx plus x squared. Now, the term that's important is x. We're looking for an answer for x in terms of d. So we need to collect terms. So I'm going to expand again by distributing the 2. Then I'll move the x to the other side. And there's our quadratic. Now, looking at this quadratic, I'm trying to see if it factors first. Excuse me?
Plus x squared, right?
Yeah. Is that okay? It's there, right?
Yeah.
You chose to sit in the back.
I'm almost back here with you. I can see it just fine. It's pretty good, right? Okay. Yeah, it's your fault. So, how many different ways do you guys know that to solve this? If I'm gonna name a way and you say if you know how to do it. Do you know how to factor?
Yeah.
Is this factorable? I don't believe this is factorable. But you can always factor if you know what the factors are. I just don't know what the factors are. So I'm going to say this one's unfactorable. Completing the square. How many remember how to complete a square? 2 of you? Once you learn the quadratic formula, completing the square seems arbitrary and unnecessary. But you could complete the square. So our last option is to just use quadratic formula. And that's all there's left. So negative b plus or minus the square root of... and I don't even know why I'm writing it down. B squared minus 4ac. I guess I'm writing it down because there's always somebody in here who doesn't know it. So, I don't know. I had to sing the stupid song when I was in 6th grade. So, in this case, and here's where we will have students who have trouble with this. This entire term is c. Just this portion of the term is b, and there's an implied 1 here, that is the a. So, we're going to have 4d plus or minus the square root of 16d squared minus 4 times 1 times 2d squared, all divided by 2. Any questions about that? All right. Since all of this is symbolic, because it's all in terms of d, algebra mistakes tend to show up right here. These 2 terms under the radical have to be in the same term. They have to be able to be added together, which means they had to have a d squared term for both of them so they could be summed. If they didn't, then you made a mathematical mistake and you need to go back. But this one we can just add these together, so that's going to be 16 minus 8, so 8. So we will get 4d plus or minus the square root of 8d squared divided by 2. This can be, we can factor out a 2 from the radical, and we'll get 4d plus or minus 2 radical 2d squared, all divided by 2. This allows us to get rid of the 2 on the denominator. And if we keep doing this, we will get d plus or minus, no, not d, 2d, plus or minus radical 2d squared. Now, you could factor out a d, and I don't know why I'm continuing this problem, but I am. So I factor out a t, and I'll have 2 plus or minus root of 2. 2 answers. I'm thinking only one of these answers is correct and one is incorrect. Which one is the correct answer? The plus or the minus? I think it's the minus. And I want to be critical about why. You need to make sure you know why. Can x be bigger than d? Let's go back to the original problem, why we're doing this in the first place. Can x lie outside of the range of d? No. There's no place over here where if I place the particle, it will have a net force of 0, right? If I place the particle here, then it's going to experience 2 forces, and they will be in the same direction, either to the right or to the left. Similarly, I can't place the particle over here, same idea, right? X has to lie inside the distance of d, so my final answer here has to be a number that is less than d, which means this has to be a number that is smaller, right? It has to be less than 1. So the only correct answer there is going to be to subtract the square root of 2 from 2, and that gives me a value less than 1. Fair enough? All right. And yeah, that kind of level of reasoning I think is appropriate for this class. All right. We never chose whether little q is positive or negative. Does that matter? If the particle had been negative, would it have changed our answer? It would have swapped the forces, right? But it would have swapped both forces. And therefore, I'd still be in the same kind of equilibrium condition. Wouldn't you agree? There is something different, though. and you do need to pay attention to this. If Q is positive, then we're in a condition of equilibrium, but it's a fragile equilibrium. If Q is positive, I want you to think about this for a moment. Let me just draw this again without so much distraction. So I need a connecting line just to help me out. So if Q is positive, and both of these Q's are positive, one was 2Q and one was Q, then we're aware that this charge pushes this charge this direction, and this charge pushes this charge that direction, right? That's the whole point. So the system's in equilibrium only if I can find that one special place. But if Q is placed here, just a little bit above that line, will the particle be drawn back into equilibrium or pushed away from the system? Pushed away. So this is a point where we don't really have a good equilibrium position, right? This is a possible place where just a small change in its position would push it away and would not be there for it all, right? Now, if this term were negative, would that be a stable equilibrium? Yeah, if a small deviation would pull the particle back into position, not send it off into the universe. So there are differences between having it positive and negative about what that equilibrium is like. You can have either a stable equilibrium or an unstable equilibrium. So if Q is positive, if lowercase q is positive, we have an unstable equilibrium. If Q is negative, we have a stable equilibrium. Small as potatoes, but still. All right, we good here? That's unlikely to be the level that I'll need you to work. Let's take a look at the first level that I'll probably really need you to work, and this is where I think the problems begin to change a little bit. So, you guys choose. Do you want me to go up like a little step? Or are we ready for like a big boy step? Or maybe a big girl step?
Okay.
Yeah. We're going to go with a little baby step. Sorry. I have to feel the room out. All right, so this is the baby step question. Let's say the separation distance is again D, and this is an equilateral triangle. Can you come up with an expression for the size of the force on the red charge? Do you guys know what I'm asking you to do?
Yeah.
Do you need, to me, this is a small incremental change, but it adds something. Not much, but it does add something. And there's an easy way to do this problem, and then there's a slightly longer way to do this problem. But why don't you set this problem up? See if you can just get it set up. Because for the most part, this isn't a terrible question. But some of you are going to struggle. So I'll give you like 2-3 minutes. I want to come and see what you guys have set up. So although many of you have set up and established that there's a force between these two particles, either retractive or repulsive, but it's going to be QK over D squared. And that'll be the force on that particle. And some of you have gone so far as to recognize that between these two, there's also a force that is going to be of equal magnitude. That part's that's the only part that involves Coulomb's law, but this problem is a vector problem. And the vector nature of that problem requires that you consider the vector portion of the answer. There is a force between these two particles that is in this direction. Come on, palm rejection be damned. Let's try again. So a force this direction between those two particles, and a force in this direction between those two particles, If I assume Q is positive, if I assume Q is negative, I just reverse those two. I'm going to leave it like this, though, for the time being. Are we all good? This problem has what we call exploitable symmetry, meaning I really don't have to do this problem twice. I recognize that there are components of my answer that cancel out and components of my answer that add together. So in order to answer this question successfully, we probably need to establish a coordinate system in order to apply our answer to. This is something we will commonly do. So as you're trying to figure out, maybe a sequence of steps for how you solve these problems, what you probably should be adding in your notes is that this is a force, and forces have a vectorial portion to their answer. And anytime there's going to be a vector portion to your answer, you need to establish a coordinate to apply the vector answer to. Again, this is a force. Forces have a vectorial portion to their answer. Because of that, you will have to apply a coordinate system in order to base your vector portion of your answer. I think there is a clear and obvious choice here, and that choice is to bisect the triangle and call this maybe the y direction. And if I'm only looking at that yellow force, then there is a component of the answer along the y direction, and there is a component of the answer perpendicular to that in the x direction. You guys follow that okay? Now again, exploitable symmetry. If I look at the red arrow, I know it too is going to have two components. It will have a component in the y direction. And I think that component will be the same size as the other forces component. But it's also going to have a component in the x direction, and I think that one will be the same size. But they'll be in opposite directions. So I believe the x components will cancel out, and the y components will add together. Now, I hate to do this to you guys, but I need to make sure I emphasize this. Trig is a big part of this class. And your capacity to do trig is going to be always on display. You need your trig to be tight and fast and be at your command at a moment. There is clearly going to be a force in the x direction and a force in the y direction. And you will constantly be needing to know which trig function is going to be the best here. I'm going to call this theta for right now, even though I think we're all pretty aware that it's 30 degrees. Right? That's not an accidental thing. Right? It's a equilateral triangle, all the angles are 60 degrees, and we just bisected the angle. That's got to be 30 degrees. That kind of fast knowledge needs to be at your fingertips. But in the x direction, this force is going to be based on the sine component, and in the y direction, it's going to be based on the cosine component. Just by the way I've laid this out, this is a case-by-case decision. Don't assume that x is always going to be sine and y is always going to be cosine or anything like that. You establish what you consider to be your y direction or your x direction, and then you make your angles relative to whatever established coordinate system you've made. So based on the way I've done it, that's the way it would be. And I don't even need to worry about the x direction. I know those two components cancel out. So all I have to worry about is the y direction. So in my answer, I'm going to say the net force in the y direction will be 2 times, because there's two components of the y direction force. QQ over d squared times cosine 30 degrees, or square root of 3 over 2. So it would probably be best to go that one step further and state your answer as square root of 3 QQ over d squared. Just cancel that 2. How are we doing? All right? So does this problem change very much if this charge is negative down there at the bottom? Changes a little bit, doesn't it? Do you know what your answer would look like if I just put a negative sign there? Let's see. I just want to see it on your paper. This one should be pretty easy. Should be pretty straightforward. So changing this one charge really just had the result of taking one of these forces and moving them. So, see if I can do this. Isn't that what happened? So, the size of the force hasn't changed. All it did was reverse its direction. But that has a pretty big impact, doesn't it? Because now the y component of this force cancels out. There was two forces that way. Now I've got two forces this way. The two y components are canceling out. This one's gone. And the x component is what's left. It doesn't change much. It just means that this will be sine 30, right? I'm going to double the horizontal component. And sine of 30 being just 1/2, just get rid of that square root, and this should be my answer. You want it to just be a tiny change. That was a tiny change, right? A little more, a little level of difficulty. You want a big change of difficulty, then here's the big change of difficulty. Get rid of all of this. Maybe even get rid of these guys. And now, instead of one being negative and one being positive, what if this one is 2q and the other one's q? I'm going to be honest, we just took this from being what I feel is a level 1 problem to being a level 3 problem. I don't know how successful you would be on a problem like this. What you have to do is the same, but are you going to have that exploitable symmetry that we just had? No, you're not. You lost the symmetrical advantage. See if you can set this problem up and see if you can get to a point where you could solve it. Now, I looked at your notes as I walked around. One of the things your notes is missing is you've done an excellent job, as always, of writing down what I wrote on the board, but with nothing to tell you what to do. So I'm going to reiterate something that you may want to establish in your notes, because this is just an equilateral triangle. You understand it doesn't have to stay that way, right? So the first thing I would iterate into your notes is decide what's your coordinate system going to be so you can make adequate and appropriate measurements based on your relevant coordinate system. And then you will have to find the components of the force, the x component and y component. The hard question here is to ask, what is the angle of the force on the particle? That's a challenging question, and I challenge you to see if you can come up with a way of solving it. It's tough. So I'm going to give you several minutes. Work at your tables, talk to your neighbors, and let's see if we can come up with what we would have to do after you get your components to finally get the direction of our answer. Without spending a lot of time rehashing what we already know, can we kind of come to grips with the fact that there are two components in this direction and one is twice as big as the other? So not a whole lot to do there except say maybe this one is q k over d times the cosine of 30 degrees. And this one is 2q k over d squared times the cosine of 30 degrees. Right, those are the two components in that direction. And I would have to add those together. So if I add those together, I think I'm getting 3. So
3 root of 3 over 2 q k over d squared in the y hat direction. That all good? You're going to do the same thing in the x direction, right? Except one's to the right and one's to the left, so you'll have to subtract them. All right, we'll pick this up tomorrow.